Hey guys. Hey, we're going to start moving into series now. And basically, a series is like a sequence. You're going to get a list of numbers, but now I want to find the sum of that list of numbers. I want to add them all up. And so we have a new symbol that you're going to use or start to see. It could be written out like a sequence with plus signs in between them, but a series also could use what's called a summation, okay, or the sigma notation. And basically, when you see right here, when you see a sigma notation, you know it's a shortcut for I got to find the sum of something here. So this bottom number is going to be my start. That's my starting point. And then I'm going to finish up at 16. That's going to be my ending point. And I'm going to use all the numbers from 0, including 0, to 16. So I wrote, and here's the rule. So they're always going to give you a rule. So now I'm going to take 0 and plug in 0. So I have 2 times 0 plus 1. So I started writing them out here. So 2 times 1 plus 1, 2 times 2 plus 2, and then dot, dot, dot until you get to 2 times 16 plus 1. And so if I do that, now I figure this out. 0 plus 1 is 1, 2 plus 1 is 3, and I get 5, and so on. And in the last one, that's going to be 33. And so I want to add all those up, and we'll worry about that later. But for now, you got to understand what this symbol means and what numbers it gives you when you plug them in. If you look, they're going to ask you on your IXL, is it arithmetic? Is it geometric? Is it neither? Is it both? So if you look, if I go from 1 to 3, 3 to 5, I'm jumping by 2s. So your difference is 2. That's going to be arithmetic sequence. All right. So another way to say all this is I want to find the sum for the rule of n plus 1 for the terms 0 to 16. All right. So how many terms are in this series? Well, here's what I do. I'm going to take 16, subtract 0. A lot of people think that it's 16. Well, when you subtract it, you really don't include 0. But I do include 0. So what I do is I subtract them and then add 1 for that last number right here. So I'm going to have 17 numbers in this series. Okay? So in the next question, they're going to ask you, is this a finite or is it an infinite series? Well, this one's going to be finite because it's going to end at 16. If you see this infinity symbol at the top up here, so let's say there wasn't a 16 and you had that, then it'd be an infinite series because it'd keep on going. Those numbers would just keep on going. All right, let's look at a couple more examples you're going to see. So I want the sum of, I rewrote it here for you, 2 times 3 to the n minus 1. I'm going to want it for 1 through 50. So I started writing out 2 times 3, and then I took 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1, dot, 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 50 minus 1. And then I got 2 plus 6 plus 18 plus 54 plus, plus, plus. Okay, so now they're going to ask you, what's happening from 2 to 6, 6 to 18, 18 to 54? Well, it goes up fairly quick. So what happens is my R, my common ratio, that's going to be 3. So what type is this? This is going to be a geometric. How many terms are in it? Well, 50 minus 1 is going to be 49. Add 1 for the 1, and I'm going to end up with 50 terms or 50 numbers in that sequence. And is this finite or infinite? Well, it ends at 50, so it's going to be a finite series. Okay? All right, next example. Slide my paper up here. All right, so now you're going to see I'm going to go from 8 to 44, and there's no variable here. So basically what they're basically saying is I go from 8 to 44, and I'm going to go 2 and 2. It's always going to be 2, and 2 and 2, plus 2, plus 2, plus 2, plus 2. All right, so now you got to figure out, well, what's 2 subtract 2? Well, that's 0. 2 subtract 2, that's 0. 2 subtract 2. So my difference is going to be 0. Well, let's check for a common ratio here. So what's 2 divided by 2? Well, that's 1. 2 divided by 2 is 1. So what type is this? It's actually both arithmetic and geometric. How many terms are there? So take 44 minus 8. That's 36. Add 1, I'm going to have 37. And stops at 44, so it's finite. All right, last one you're going to see. You're going to run from 0 to 12. N minus 2 squared. Well, someone's going to think, well, that's geometric. Well, I started writing out the numbers here for you. And that's how you set it up. I'm going to get 4 plus 1 plus 0 plus 1 plus 4 dot dot dot. So I'm not going, I'm dropping and then I start gaining again. Well, this is neither. Okay. You may see one where it's just n cubed and think that's geometric. Well, if I cube it, I'm going to get 0 plus 1 plus 8, that's 3 cubed, or 2 cubed, plus 27, which is 3 cubed, plus 4 cubed, okay? Now that's not, there's no common difference, there's no common ratio. I don't multiply by the same number, so that one's going to be neither too. And the last thing you want to look at is, again, if there's a infinite symbol up here, this is going to be an infinite series. All right. All right. Good luck. Should be pretty easy. Have a good day, you guys.